Welcome back. This is section 10.5, which is implicit differentiation. Now, before I start explaining, I really wanted to again repeat that please start with reading your textbook first, because this is an online course and it is very important to use all the resources. And please do not expect every homework problem to be solved, because that is not the way of teaching. So I cannot be solving every homework problem. So I highly recommend starting with your textbook, read the concept so you can understand what's going on. Take a look at the PowerPoint examples and you have all these help me solve, watch a video or step-by-step instructions and worked out problems also. And I would recommend using this homework problems or this video as a resource while you're working out the problems, just to help you with understanding those simple things that you missed while you're reading. But without doing the proper prep work or foundation, you cannot be working with your homeworks. Now, having said that, let's take a look at what implicit differentiation is. Now, you might say, Miss, we've been doing differentiations. How is it different from the previous one? The word implicit differentiation means that you're differentiating on both sides of the equation and then solving for the y prime. So what do? You first differentiate the function using the rules, that is dy, y prime or dy by dx. For the variable y, you remove the parentheses, group all the y primes on one side without y primes on the other side, factor if necessary, and solve by dividing. Now all this is going to make sense once we start working with the problem. So here I have a problem. They say, hey, you have the equation 6x plus 7y plus 5 is equal to 0. Differentiate the given equation implicitly and then solve for y. And the second way is just find y and then differentiate. Let's go ahead and do both ways. So I'm going to draw a line here so I can differentiate. So I have 6x, I have 6x plus 7y plus 5 is equal to 0. So if I start differentiating it, this is called implicit differentiation. Derivative of 6x is 6 plus derivative of 7y is 7. But remember, you're differentiating y with respect to x, so you have that y prime. Or you can even say dy by dx. Derivative of 5 is 0 is equal to 0. And now how do you solve for y prime? You subtract both sides with 6 and then divide by 7. So y prime is negative 6 over 7. This is implicit differentiation. Now let's go ahead and do the same thing. 6x plus 7y plus 5 is equal to 0. Now I'm going to solve for y first. So my 7y is equal to negative 6x minus 5. Divide by 7, divide by 7, divide by 7. So my y is negative 6 over 7x minus 5 over 7. And now if I'm trying to solve for y prime or differentiate this, differentiation of negative 6 over 7x is negative 6 over 7. Differentiation of a constant is a 0. So as you can see, it doesn't matter how I do, I will still end up with the same answer. One is implicit, that is, I'm just differentiating right here and then solving for y prime. And the other, I'm solving for y and then differentiating it. Now let's take a look to see if the equations match. Yes, they do. 6 plus 7y, and this is my differentiation, negative 6x, negative 6 over 7x, negative 5. There you go. Okay, so that's exactly what implicit differentiation means. You will differentiate first and then solve for y prime. What do we have here? Use implicit differentiation. Very good. And evaluate y prime at 2, 5. Let's see what we have. Differentiation of y is y prime minus differentiation of 4x cubed is 4 times 3x squared. Differentiation of 7 is 0. So 0. Very good. What do I have? This gives me y prime minus 12x squared is equal to 0. So my y prime is 12x squared. They didn't say stop here, they say evaluate. So I'm evaluating at 2 and 5. That means my x is 2, my y is 5. Let's go ahead and plug that in. So when I plug my y prime, 12 times 2 squared, there's no y to plug, so I'm not going to plug it. Y prime is equal to 12 times 4 is 48. Now let's see if our answers match. Drum roll, please. There you go. So find your y prime and then plug in. Let's do one more. I'm going to do it right here so you can see. Derivative of y squared is 2y. Don't forget the y prime. Remember, you're not differentiating it with respect to y. You're differentiating it with respect to x. Derivative of 5y is 5y prime. Derivative of 6x is 6 is equal to 0. And now what do? I'm going to bring all of this down here so I'll have more space to work. I'm going to separate my y prime, or I'm going to factor out my y prime. So when I factor out y prime from here, y prime from here, what do I have left? 2y plus 5 plus 6 is equal to 0. Remember, my goal is to get y prime by itself. So what I'm going to do is I am going to kick the 6 onto the other side, which makes it -6. And now I am simply going to divide both sides with 2y plus 5. And that's my y prime. I'm not done here. They said evaluate at, what were the numbers? -6 and 4. Evaluate at -6 and 4. That means my x is -6, y is 4. Let's go. I don't have an x to plug in, thank God, so I only have y. 2 times 4 plus 5. So it's -6 over 13. So my answers are -6 over 2y and -6 over 13. Let's see if they match. There you go. Now let's go ahead and take a look at, do we have another problem? Yes, we do. We have all the way in the bottom here. Now let's go ahead and take a look. And keep in mind, I cannot do every problem, and MATLAB does generate problems similar to this. So having an expectation of every problem being solved in the homework is not the right way to look at it. So please, again, if you have any questions, all you have to do is take a screenshot and put it in the discussion so I can help you solve them. All right, now let's go ahead, and it's the same thing. I'm differentiating and evaluating. So let me do this right here. Derivative of 32 EY is 30, what kind of 2 is that? 32 EY. Remember, I'm differentiating with respect to x, so y prime will always be there. Differentiation of 5, x power 5 is, 5x power 4 minus differentiation of y cube is 3y squared. I can say dy by dx, or I can just simply put that prime. Once we've done that, I'm going to bring all of this down here so I can solve this. Remember, my goal here is to solve for y prime. So it's always easy to bring all of these to one side. So I'm going to bring 32 EY y prime plus 3y squared y prime is 5x power 4. Now do you see all the y primes on one side? When I have them, what do? I factor that out. That gives me 32 e power y plus 3 is equal to 5x power 4. Now how do I solve for y prime? Simply divide both sides with 32 EY plus 3. We are not done yet. They're asking us to evaluate at 2 comma 0. Was that 2 comma 0? Yes, 2 comma 0. Now what do? Luckily in this case, I have my x and y. 5, what is my x? 2 to the power 4 plus 32, my y is 0, e to the power 0 plus, oh, there was 3y. This was y squared, sorry. There has to be a little y square here. 3y squared. There has to be a y square here. I forgot the y square. So please don't do mistakes like I did. So it's 0 squared. I completely forgot the y squared. Okay, once that's done, this is 5 times 16 over 32. Because 3 times 0 squared is 0 squared. And I end up with 5 over 2. And your final answers are going to be 5x4, 3e to y over 5 over 2. Let's see if they match. They're exactly the same, written in different order, but there you go, your final answers. Okay? And again, please be very careful. I don't want you to forget the terms like I did. Put everything together and cross-check and recheck your answers. All right, let's go ahead and take a look at the next question. What do we have here? Oh, find the equation, find the y prime, and find the slope of the tangent at the indicated point below. Very good. To start problems like this, I would always go ahead and rewrite it. I don't like to have radicals. I'm just going to put them into powers. Plus 3 is equal to 0. I'm differentiating at 2 comma 3. Once this is done, I'm going to bring everything to the bottom here so I can rewrite it and solve it. All right, what do I have? Now let's go ahead and solve. Differentiation of 16y to the power half is half 16 plus y squared half minus 1 times, don't forget the derivative of 16y squared. Derivative of 16 is 0. Derivative of y squared is 2y. Don't forget the y prime. So every time you find the derivative of y, blindly stick the y prime. Minus 3x squared. Derivative of x cubed is 3x squared. And the whole thing is equal to 0. Now 2 and 2 cancel each other. So I have 16 plus y squared to the power negative half, right? Because half minus 1 is negative half, times, I'm going to rewrite this one in the front, y times y prime minus 3x squared is equal to 0. Remember, my goal is to solve for y prime. So what I'm going to do is y prime 16 plus y squared. Actually, you know what? Because Pearson doesn't like negative powers, I am going to bring this down, because to the power negative half means radical in the bottom is equal to 3x squared. Again, my goal is to get y prime. I hope everybody knows how I got from here to radical, because negative becomes positive in the bottom and half is nothing but your radical. So my goal here is to find y prime. To do that, I will cross multiply. Let's do that. Y times y prime is 3x squared times, I don't have to put parentheses, do I? Times 16 plus y squared. And again, I need to get y prime by itself. So I divide both sides with y. And my y prime is equal to 3x squared 16 plus y squared over y. They're asking me to evaluate at 2 comma 3. Did they say 2, 3? Yes, at 2, 3. All I have to do is plug in my x, which is 2 squared, plug in my, 2 squared, plug in my y, which is 3 squared over 3. Now what do I have? 3 times 4 times 16 plus 9 is 25, radical 5. 25, square root of 25 is 5 times 3. My final answer is 20. So here your answers would be y prime and 20. Let's see if they match. There you go, y prime and 20. All right, let's take a, oh, that's the last problem. And again, if you have any questions, please take a screenshot, post them in the discussion board. So either me or other friends or colleagues who are working with the same problem can help you out. Hope this helps.